Hello, my name is Joaquin Zapata, and this will be Project 4 for Electromechanical Systems for Professor Khan. For this project, we will be working with an ultrasonic sensor to basically just depict how motion sensors work in conjunction with, we're just going to say it's going to be like a door, but it's going to be connected to a motor that spins. And that's essentially how most devices work. It's just a motion sensor. And the basic premise of this will be from our ultrasonic sensor. So the way this device works is one side will be our receiver and one side would be our transmitter. This thing sends out waves, ultrasonic waves. Of course, we can't see them, but the object can sense it and feel it. So the way it works is the transmitter will send out ultrasonic waves until it bounces back with an object. Once that object is hit with the ultrasonic waves, it will bounce them back, and the receiver will transmit that information into this device. So it reads it reads the ultrasonic waves essentially, and it also has these four prongs. Essentially, they're labeled as ground, echo, trigger, and BCC. Ground is, of course, just going to be our ground signal. BCC is going to be what's connected to our voltage. For this case, it would be 5 volts. Echo is our output signal, and then trigger is our input signal. And that's basically how this is going to work. We're going to be controlling, we're going to be make a motion sensor essentially that within a certain range, we will be able to tell if an object is nearby. It will trigger an alarm system essentially and cause our motor to spin. So for this project, we will need, of course, the ultrasonic sensor, our breadboard, an Arduino, a USB cable, a motor, and some jumper cables. I would suggest maybe getting the longer ones, just because we're making a lot of connections to the Arduino and stuff, and we don't want anything just getting tangled up. We're going to be using 2 LEDs and a buzzard. I just attached them to the breadboard just so I wouldn't lose them. But I would suggest maybe a green one and a red one, just for the sake of clearness. But yeah, let's start building the circuit. All right. So these pieces can go anywhere on the breadboard. We're going to be connecting them to the Arduino and seeing how this works. We're going to be using some code as well. It was provided by Professor Khan, and we will talk about it a little bit later. But yes, this is how it's going to be. Just the bare bones right now. This will be the one that transmits the ultrasonic waves. All right. Let's get our Arduino. So first, let's connect our ground to ground. From the ground prong, they are labeled, so you'll be able to tell easily. We'll just connect it to our ground. Our BCC is going to be connected to our positive side, which will be our 5 volts. Our trigger signal will be connected to our pin 13 on our Arduino. You'll see why later when we look over the code. And then lastly, for the sensor, we're going to connect our echo to pin number 12. All right. Well, now that's done. Our LEDs were connected with the positive and our negative side. So the positive side is on the breadboard itself, and then our negative will just go to ground, and they're both set up the same way. And then same thing with our buzzard. There's a positive side and a negative side. They're both on the breadboard currently, and we're going to connect them shortly. So we're going to get another cable, and we're going to connect our green LED to prong number 7. Then we're going to get another cable and connect that to number 6. And then our negative side of the buzzard will go to ground. You can tell which one's is negative or positive. There's going to be a symbol on it, so a plus and a minus. And then our positive side, we will connect that to prong number 2. Alright. And the last thing we need to connect will be our motor. So the way this one works is you have 3 different colored cables. Ground, orange, and red for this one. Brown will go to ground. The red will go to positive, and our orange will be connected to port number 9 on an Arduino. And then lastly, we're just going to connect the 5-volt port of our Arduino to our positive side. And then we're going to connect one from ground to ground on our breadboard. That's how our circuit will look. And now we can connect it to our computer so we can input our code. So as you can see, the green light is currently on right now. That means that no object is close to our system within 20 inches. But once we put something in front of it, the light switches from green to red. That indicates that an object is closer to it, closer than 20 inches. This will also cause our motor to spin 180 degrees. That's how we've programmed it. And our buzzard will emit a noise, of course. So just a couple more demonstrations. And that's just because of the way we've told our Arduino to act with these devices. So if nothing is close by, of course, it'll stay the same. But if we have something like a calculator, it's closer. And this is basically the basic design of it. We're going to go ahead and look at our code now. So as you can see from this, this is essentially just our basic setup. So of course, strict to 13, echo to 12, etc., etc. And sorry, this is just the pins. So the real magic behind it all would be in this part of our code. This is what essentially is our loop statement, and that's how our system essentially gets the information for it. We also have our distance calculation here. We are using velocity of the speed of light, essentially, because that's how fast our current is traveling. Um, and we are calculating the distance and then turning that distance from centimeters to inches. Our if statement here is what we explained before. If it's less than 20 inches, our light will turn red. Otherwise, it will stay green and the buzzer will not buzz. But we have both of our LEDs. Once that is through, and then of course, we also have a statement here for if the distance is greater than 200, it will be just simply out of range. We also have an else statement. So if this is true and everything is working fine, well, not if this is true, but once everything is finished with, we're going to print out our distance in centimeters and our distance in inches. And we can show it through this. So as you can see, out of range because there's nothing inside of it right now. But if I move my hand closer to it, right now. So probably right now, it's detecting my mouse. It's detecting my mouse because it's on the way of the waves. But it's still out of range. It's still a little bit far. But once I put my hand in it, and you can see the numbers, our buzzer starts to ring. The distance is getting closer. And then boom, we're back to out of range because there's nothing nearby. But that's essentially how it works. Sometimes this is out of range. Sometimes it reads an object. It's probably just things around my table. But right now, there's nothing that should be reading it. The ultrasonic waves are not getting anything back to bounce back to the receiver. And our system just stays like that. Thank you for watching.